In this video, we're going to be looking at exponential growth and decay word problems, and we're going to be using a specific formula just for it. So you can use an equation to model this situation. This is the exact same formula as the one that we have been working with. Y is equal to A times B to the X, where A is your initial value, and B is your base. Now, what we're going to do today is we're going to take that B and we're going to basically show you how to calculate it if you have a real-world problem. So we're going to use these two formulas, but if you'll notice in these two formulas here, the A is the same, but your B is broken up into 1 plus R or 1 minus R. Now, let me share with you what that actually means here. In a real-world problem, we're typically talking about a rate of growth or a rate of decay. What you're going to do is take 1 plus your rate of growth, and that's going to give you your growth. Typically we do the growth in percentages. So in other words, if it were 50% growth, then your formula would be y is equal to A, whatever your initial value is, 1 plus 50% growth. We need to change 50% to a decimal. So there's your 50% growth. So this would actually be A times 1.5 to the x power. Your decay would be 1 minus your rate. So for example, if this was 50% decay, then it would look like this. Y is equal to A, your initial amount, and then 1 minus 0.50, because 0.50 is mathematically equivalent to 50% to the x power. So y is equal to A times 0.5 to the x power. Or you could even use a half, A times 1/2 to the x power, which means half decays every time we calculate, and half remains. All right, let's take a look. So in each, I want to identify each as growth or decay. So this one is actually, whoops, excuse me, that is a no-no. This one's decay. What this means is I'm starting off with 500 of something. So maybe this is money. So this means I'm starting off with $500. And this would mean it's decay because it's between 0 and 1. Now, I'd like for you to figure out the rate of decay. In other words, 0.8 actually remains here. So what actually decays? In other words, 1 minus what? Whoops, let's get that off the screen. So this was 1 take away what is going to give us 0.8. Well, if you're thinking 1 take away 0.20, then you're right. So that means actually 20% decays. So 20% decays and 80% remains each time. So in this one right here, this would also be decay, and it means you're starting off with 6 of something. That's how much you have to start with. But this means that 75% remains and 25% actually is your rate of decay. So that means 25% actually wears away each time. So if we look at the next one, this means we start off with 300 or something. Here we have, again, this is decay. And what this means is that 60% of whatever it is that we're talking about actually remains. And 40% decays or wears away. Okay, continuing on. What this means, this is growth. And this was 1 plus what gave you 1.5. Well, if you were thinking 1 plus 0.5, then you're great, which means 50%, right, is what it grows by. So at the end of, say, every year, you're going to have 50% more than what you started with. That came from 1 plus 50%. This means that you start with 60, let's see, 60 of something, and this means it was 1 plus what gave you that. So if you're thinking 1 plus 0.3, which is 30%, then you are exactly right. So this means 30% growth. So at the end of, say, every year, you have 130% total. That's what you have remaining. This means you start off with 100 of something, and since 1 plus 0.05 gives you 1.05, this means that 5% grows. Okay, let's take a look at some problems here. So here we have Brian, and he memorized 15 Spanish vocabulary words. If he memorized 20% more words each week for the next 10 weeks, how many would he have memorized? So he got 15 Spanish words total. He memorized 20% more. So this is growth. And we want to know if he does this for the next 10 weeks, how many would he have memorized? So here we have y is equal to a times 1 plus your rate to the x power, x being your time. So y is equal to, now a is the initial, that's your 15. He already started with 15 words, plus 1 plus, now 20% more, so 1 plus 0.20 to the x power. Your x is your time. So in other words, how many times are we actually calculating this? And it's for 10 weeks, every week for 10 weeks, so that's going to be 10. So we have y is equal to 15 times 1.2 to the 10th power. Now we just have to punch that in our calculator. So I'm getting 92.876, which means how many words would he actually have memorized? Well, he wouldn't have that 93rd one memorized, would he? So we're going to say 92 words. Let's try another one. Maddie has an account that she withdraws. Okay, that means this is going to be decay. Okay. 5% from, there's our rate. So that's our R, that's our rate. If the account currently has 50,000 in it, that's our A, that's our initial value. What will be the value of the account in 10 years? Okay, so here we go. Y is equal to A times 1 minus the rate to the x power. Y is equal to 50,000. And then it's going to be 1 minus 5%. So I got to be careful. So it's 0.05. 5% is 0.05. Now it's every year for 10 years. So your exponent here would be 10. We're going to do this 10 times. So the equation is y is equal to 50,000 times 0.95 to the 10th power. So what this means is 5% actually decays, but 95% actually remains. So now with my calculator here, I'm going to calculate this. So we end up with, and this is money, so 29,936 point, and I will round this because it's money, 85. Now this is how much remains. Be very careful, because if they asked you how much did she withdraw, that's a different question. So this is how much remains in the account after 10 years, but if she wanted to know how much she withdrew, she would have to do 50,000 minus 29,936.85. And I'm just going to calculate that real quick so that we know if you're curious. So that means she actually withdrew $20,063.15. Okay, so that's how much she withdrew basically over the past 10 years. So the formula gives us what remains. If you want to know what was actually decayed, you're going to have to subtract it. It's very important. Okay, Jessie received $75 for her birthday. In the first week after her birthday, she spent a third. In the second week and each of the following weeks, she again spent one third. How much money did she have after 5 weeks? So this is going to be decay because she's spending the money. It's decreasing. This is going to be our A. And one third is going to be our rate. That's what actually decays. So our formula is y equals a times 1 minus the rate to the x power. So y is equal to $75 times 1 minus 3 to the 5th power. So y is equal to 75 times 2/3 to the 5th power. Okay, so what this means is 1/3 is actually being spent each month, but 2/3 actually remains in the account. Actually, I shouldn't say per month, it was each week. So y is equal to, let me punch that in. So $9.88. Now that, again, just to reiterate what this formula gives you, is what remains. If you wanted to know how much spent, you would have to do $75, take away $9.88. So that means she spent $65.12. Okay. All right, between 1970 and the year 2000, the population of Catayatown, thinking of Mr. and Mrs. Cataya there, has decreased by approximately 4% each year. In 1970, there were 870,000 people in Catayatown. To the nearest thousand, what was the population in the year 2000? And then I'm asking you a follow-up question. How much did the population change since 1970? Okay. So it's decreasing by 4%, which means this is decay. All right, so we will move this. So essentially what we have here is we have the initial amount, 870,000, and then it's decaying at a rate of 4%. So be very careful, it's 1.04 to the 30th power. Calculate that, you end up with 0.96. It means 96% actually remains. So 4% leaves, but 96% stay. That gives you approximately $250 255,656. Now, the question actually said, how much did the population change since, well, what was the population in the year 2000? Well, this is your population in the year 2000 because this is what remains. So that's how many people remain. If you want to know how much did the population change, or in other words, how many people left, again, you're going to do that 870,000 and you're going to minus the 255,000 656 people. So that means 614,344 people left. Okay, let's try another one here. So Amy's parents invested 14,000 at 6 years, or 6% per year compounded monthly. Oh, actually, you know what? We're going to skip this one. Let's skip this one. This is a little bit unique because it's per year, but we're doing it monthly for 10 years. So we're actually going to skip that one. It's a little bit more complicated. All right, if we were in our classroom right now, we'd be working on some whiteboards, but we're not. So what I'm going to challenge you to do is actually on our Teams page, if you go to the post for this or if you go into files, you will see your homework for this. There are 17 questions, but several of them are very, very quick. I'm putting it on the Teams page because it is from a website that would like us to do this password protected. So I can't put it on my website. So I can put it on my Teams page because we have passwords to get into that. So go to the Teams page, either look at the post or go into files and you'll see it there. Good luck.